Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from São Paulo, Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer. I will now turn over to our speaker for today. Thank you and welcome, Johan.
Hello, I hope everyone can hear me. Trust
Yes, we
everyone
can
can
hear
hear
you.
me. All right. So good morning, good afternoon, wherever you are. Welcome to session number 5. I'm actually in South Africa this week, so I'm sitting in a hotel room. Probably my picture is not as clear as usual, but today we've got an interesting topic. This is session number 5 of 11 for the Azure Developer Certification. You would have noticed that in the hour we talk about these different services. It's not enough for you to cover the exam if you're not familiar with these services. So go look at the certification links. I think we've shared most of them. Go look at those certification links, look at the material under that, and go through the content at your own pace as well before you're going to attempt these exams. So I'm going to deal with the concepts here. We will look at some specified deployments possibly. And just a short agenda, we will introduce containers and the Azure Container Registry. The Azure Container Registry has become a big part of this certification. You'll notice if you go through the course material that we talk a lot about the Container Registry. Initially in this certification, we just mentioned the Container Registry and use it for storing images. Now we're talking about, as part of the certification, things like building images and running tasks and things like that. So the idea would be to understand basically what are containerized applications, how do they work, how do you create a containerized application, and then the second part, essentially this section down here, we will talk about how to run these containerized applications inside of Azure. And the two services that the certification requires you to get under the belt is Azure Container Instances and Azure Container Apps, all right? So Azure Container Instances are very simplified, very simple, easy to manage, delete and recreate if it's not working type of scenario, just a single instance. And with Azure Container Apps, we basically have that capability of getting scale and ingress. And you'll notice under the covers, Azure Container Apps actually is basically a Kubernetes cluster. And then we'll wrap things up and see if there's a few questions. Okay, so I'm not gonna execute as much code and commands and things this week. Some of the services that we provision in this learning path actually takes a little bit of time to provision. But let's first introduce containers and understand what containers are. So if I have to contrast this with something like standard type applications, you've always got your source code, right? And in my case, my source code sits in something like GitHub, and that source code is essentially what you're going to be using to build your application. And very often what happens is the source code is fed into some sort of a pipeline, typically a continuous integration pipeline. And from there, we do something like a build, and we do something like a deploy, CI/CD. Sorry about the writing. I'm using my finger to write in whiteboard this week. So in actual fact, I might actually use the mouse. That might be a little bit better. So if I was using something like a virtual machine scenario, we all know the virtual machine has always got some sort of a physical host that's hosting the virtual machines. But then there's a bit of magic above that. Typically, if you're using the Microsoft stack, you're using something like Hyper-V. There's a hypervisor on those hosts. And that hypervisor knows what to do oopsie, knows what to do in order to get, a virtual machine running on top of that host. Now, what the virtual machine has is the virtual machine has got a full operating system. So there's an OS there. It obviously also runs and contains all the different components that you might require to run your application. For example, this might be something like the .NET framework. And then, of course, it's got your application sitting right at the top there. Now, the way to scale this, if you were running virtual machines, would be to spin up additional virtual machines. Different .NET frameworks that you need to keep updating. Also, you need to keep updating that operating system. So you have to manage those virtual machines as if they were standalone, full-on, hosts, and they actually are. If we pivot this towards a containerized solution, your containerized solution also still runs on some sort of a host, except in the case of containers, the host can be a virtual machine. It can be a physical host like my laptop here. It could also be that, the host is something like a Raspberry Pi type device. Right? That's also possible. Now, when I'm running containers, there's two additional moving parts here. Part of my source control is something called a Dockerfile. And let me just grab this and type there quickly. Dockerfile, right? And this Dockerfile will essentially contain all the commands to build a container image. The other moving part, or the other building block in a containerized environment, is something called a container registry. And a container registry could be something like Docker Hub that you are using. Docker Hub is for container images, what GitHub is for source code in a sense. But the difference is now when I'm building, when my source code changes and I want to create a new release of my application, I'm still going to execute all the build commands, all the test commands that make up my continuous integration pipeline. I'm still going to execute all of those commands, except I'm not going to generate a binary artifact out of that build process. The artifact that gets generated here is called a container image. And a container image contains what's known as the user portion or the user mode of the operating system. It's not a full operating system. It's basically enough to create a folder structure and to make the application think, there's folders. I must be native on an operating system here. The container image also contains all the different components that I need to run my application. For example, the .NET Framework 8 or 9 or 10 or whatever it is that you're using. And of course, also my containerized application. Right? Whatever that is, my .NET or my Java application. Might be an API, might be a front-end web application. It honestly doesn't matter what that is. So where we traditionally, if we were building something like native applications, this build process would have generated some sort of an artifact, but that's usually a binary artifact. The artifact that gets generated and published into the container registry, if I'm using containerized applications, is essentially what's known as a container image. And that container image contains everything required to run that application. So I like to think of these container images as almost a type of DVD. And I know how cheesy this actually sounds. But if you remember when DVDs were all the rage, I could literally say, well, I'm going to a holiday home here somewhere in the Western Cape in South Africa. I can call them up and ask them, is there going to be a DVD player at this holiday home? And they would say yes. And by the time I'm still unpacking everything from the car, my kids are already watching Ice Age on the DVD player internally. I can hear, there we go. There's the ice, here's the squirrel's eyes jumping or whatever the case is. So it doesn't matter what the DVD player was. As long as it was a DVD player, then they could play their DVDs there, and the DVD contained all the sound, all the images, all the video, everything required to watch the video, right? So just like that, wherever on the container side, wherever I've got a container runtime, something like Docker, for example. In my case, I'm running Docker here on my desktop. I was running something like Docker. I can then basically take this image that was published from my build process typically into the container registry, and I can pull down a copy of that image. I can store a copy of this image locally on my local device, and then after that, I can start creating instances of this containerized application. And what that means is now suddenly one host could be running multiple instances of a containerized application. And typically, I might even go and place something like a load balancer in front of that. What I would do on the virtual machine side, of course, is spin up additional virtual machines with full operating systems and place something like a load balancer in that. If there's an update to the .NET framework, for example, I have to touch each of those virtual machines and I have to update the .NET framework on those hosts. If I've got a containerized solution and there's an update to the .NET framework, all I have to do is just build a new container image, and it now contains the newest version of my containerized application with a new version of the framework. And that means if I push it into the container registry, and the container registry has got this latest version available, wherever I'm creating additional instances of this, it'll typically pull the latest version, and that's how I roll forward with a new version of my application. Everything required is inside that containerized image. So what I'm going to do is I'm going to first pause a bit, we'll look at a Dockerfile, and then we will look at the container registry in Azure. The exam covers quite a bit from that. And then we will talk a little bit about authenticating against one of these container registries. So in my case here, what I'm going to do is, you can see that I've got something called container registries. There you can see I created a container registry earlier called Jazz 204 ACR. By the way, if I create a new container image, a container registry, you will notice that I can essentially scope whether this container registry is going to be accessible from everywhere in this tenant, in the subscription, or only from a specific resource group for that matter. So you can scope essentially, how accessible it's going to be. You'll also notice that there's a basic, standard, and premium plans. And the reality is, if you look at the different versions, then you will see it's different amounts of storage you get with these different, SKUs. And then on top of that, you will see towards the bottom here, you will see that there's things like geo-replication, the ability for me to make sure that the container registry is available across multiple availability zones, content trust, private link with private endpoints, the ability for me to take away that public-facing access and surface the container registry just on a virtual network. All of these are typically supported on the premium plan, but that doesn't mean you cannot get value out of the basic and other types of plans. You might also find that there's also things like webhooks here, and you can see the number of webhooks could be 500. What that means is I can actually go into my container registry here, this ACR that I created, and you will see if I scroll down here and I go to webhooks, then I can actually say, hey, I've got a webhook, and this webhook is going to take this information, and there you can see I can specify the URI of the service, and then I can specify what actions I want that webhook to be triggered. And what it's going to do is, if I search for Azure ACR schema, webhook schema, I'm just doing a Bing search there. There you can see webhook schema, and you can see if I scroll down a section, this is essentially the information that will be available via that webhook. There you can see the action was a push action. The target was that specific, sort of media type in that specific repository, and then you can see that there's the host, etc., etc. So it's definitely something to think about if you want to get notified when there's new container images. That's definitely something that you can also do. And of course, remember from our function apps option, you can build one of those webhook services by just using a logic app, right? And giving the logic app HTTP endpoint an example of that schema that I just showed you. There's my geo-replication options. If I upgrade to the premium plan, I'll be able to select South Africa, North, and a couple of other places, and it'll essentially allow me to replicate those container images into those different regions. There you can see something called tasks, and the reality is, if you take a look at this task at the bottom here, you will see there ACR task, create the name of the registry, a name for the task. You can see there task hello world, the image I want to be creating, and you can see there Jazz 204 acr.azurecontainerregistry.io, Docker app latest. The context I'm giving to it is essentially that GitHub repository, and you can see I'm referencing essentially the main branch by that. And every time there's a push on the main branch, it's essentially going to trigger this task, and this GitHub access token of mine is essentially going to give the container registry access to pull the source code over. You can see there's the Dockerfile. It's basically going to find the Dockerfile in the root of the repository, and it'll then essentially build this out. So what I'm going to do is I'm going to copy that just quickly, and let's see if we can make this work. Okay, so ACR name here. Jazz 204 ACR. I'm happy with a task name. There you can see Jazz 204 ACR. That's the name of the container image that's going to get created. That's the context. I'm pointing it to my GitHub repository. You can see it's specifying the Dockerfile, and there's that access token. I'm going to run that, and it should take a few seconds for this to complete. Come on. There we go. If I go back to my container registry now, and I look at tasks and I refresh here, you should see there's a task hello world, and you'll notice that it's essentially being triggered with a source code repository push. So a merge on the main branch in this case, pull request or just a standard merge. Now what I'm going to do is I'm actually going to trigger it, right? So I'm going to go to GitHub. I'm going to go to my Docker application there, and I'm just going to make a change to the README file, right? Remove all of this and say keyboard issues. I cannot find my hash, so all I'm going to do is just say hello. I've got a different keyboard here today. It's a bit strange. All right, I'm going to bypass all my rules. This is going to create a merge on the brand branch. And if I go for runs now, you'll see that there's a run. It's actually running at this point in time. You will actually see it's going to download the source code repository, and it's essentially going to start building out that container image. The container image is going to be built based on this document. There you can see there's a Dockerfile, and you can see that this Dockerfile is essentially what's known as a multi-stage Dockerfile. That is one stage. This here is another stage. And what we're basically doing here, folks, is we're starting off with a .NET SDK, right? Then we are build as the build environment. We are then really running some .NET restore commands, copy the source, doing a .NET publish into the publish folder, and then we are throwing away this .NET SDK. We don't need the SDK to run the application. So then we are throwing away that first part, and we're starting a new year with just the ASP.NET framework, and then we are copying the result of the build into the current directory, exposing a specific port. You can see the exposed port 80, and then we're providing an entry point. So if you're using something like a CI/CD pipeline, you might be doing a .NET restore and a .NET build and these sort of things as part of your pipeline. You might be duplicating some of those commands in here to essentially get your binaries into the right folder structure. So what would have happened is this run would have essentially pulled that repository. It would have used that container image, and it would have essentially built out, the Docker app container image. And you can see there's Docker app latest. If I wanted to, I can actually execute something like a Docker pull command, right? In this context, Docker pull Jazz 204 ACR if I wanted to execute something like that. So the container image is in there. I do want to just quickly touch on a couple of other things. I've mentioned webhooks, I mentioned geo-replication, I mentioned tasks. There's different types of tasks. I might want to just touch on that. You can see that we've got something called a quick task. And a quick task is essentially, I can actually, as opposed to hooking up to the source code repository, I can say ACR build and tell it where the Docker file is. It will then zip up the content, move it over to the container registry, and actually start building that container image. The second one here is triggered. This is essentially based on a source code push or something like that. And then we've also got something called a multi-step. With multi-step, it's actually quite nifty. You're able to, for example, build a container image, maybe something like a backend API, and then you can run the container image, and then you can build and run a web front end to that and check to see if the web front end can connect to the backend. And then after all of that is done, it'll destroy all of those, and the container images will be stuck. So you can actually even do some testing in the container registry if you wanted to do some of that. Geo-replication, I think I mentioned that. Regional storage that gives you the container images locally. I mentioned zone redundant, but there's also a caching component, and there's also a hybrid component. So for caching, if we find that in our containerized environment, we often use Nginx, for example, for things like SSL termination, then we can cache Nginx on our container registry, and that means every time we use Nginx for whatever we're using it for, as a base image, for example, it doesn't have to pull Nginx from the internet, for example. It's got a local instance of Nginx. And then we've also got a hybrid component that allows us to synchronize the container registry with an on-prem container registry. All right, so there you can see there's something called connected registries, and you can see connected registry is an on-prem replica that essentially synchronizes my container images. More or less a hybrid type approach, but you'll also see that there's a caching component here, and the caching component allows me to create additional rules. There I can say this is the Nginx rule. I can point it to Nginx latest, just as an example. That's a typo. I'm actually not going to execute this, but you will see it's also prompting me here for a credential set if I needed a credential set for that. In fact, credentials are not optional. And then you can see I can specify that what I want to call it. And that allows me to cache whatever container images I'm using as part of my container images on the container registry. Doesn't have to pull them from the internet each time. Lastly here, there's a couple of ways to authenticate. Now, you would have seen in the first example where I executed this command here, and I created that task to build a container image, you would have noticed that I used AZACR. AZACR, the Azure command line interface, essentially uses integrated authentication for me to be able to interact with the service. But what if I don't have integrated authentication? What if I need a credential set? For example, if I was using something like Docker Desktop is not got integrated authentication. So for something like Docker Desktop, it's going to be expecting some credentials. So how do we do this? Inside the container registry, by default, if you create it, by default, I can only authenticate using integrated authentication and something at the bottom they call tokens. I'll talk about that in a few minutes. If I needed to use something like Docker, for example, what I might have to do is I might have to enable the admin user. So if I just give you an example here, I'm going to see if I can just quickly start up my Docker desktop. So there you can see there's the latest image. I'm going to copy this command. All it's really doing is it's doing a Docker pull, and it's pulling the latest version of that container image. So I think Docker is actually starting up now. But if I go into my command line here and just clear it out, and I execute that command, you'll see it's going to fail. And the reason it'll fail is because it's trying to connect to that container registry, but the container registry is saying, hey, who are you, right? And at this point in time, Docker doesn't have credentials. So you can see there, it's prompting me for a username. Now, if I have not enabled this, then I won't be able to do this. You'll notice if I go to my access keys here, and I say enable the admin user, what it's going to do is it's going to give me a username there. There you can see there's the username. I'm going to copy that username, paste the username in there, and then the password for that. I'm going to copy and show the password, paste the password, and I'm authenticated. Authentication required. Let's just try that again. Docker login jazz204 acr dot Azure Container Registry.io. Username jazz204 acr. It's the same name as the registry. And I'm going to just paste that. It should actually have worked now. I don't think earlier I actually pasted correctly. There we go. Login succeeded. So if I execute this command now again, it might ruin my internet here, but you'll see within a few seconds, it's going to start pulling that container image to my local device here. And at this point in time, you should notice if I go to images here, you will see that there is that Jazz204 Azure Container Registry.io. I've essentially I've got it locally, and if I wanted to, I can actually just run this now. Run it, and I can specify something like port 8080. It's going to map to port 80, and I can say the site name is going to be local Dell. And I'll run it, and within a few seconds, if I go localhost 8080, then there you can see there's the web app running, local Dell website. If you're interested in using this demo, this is the GitHub repository that you might be using. If you just go to GitHub and you search for Sayedi Mac there, you will see on my landing page that there's a couple of instructions. This is for app services demos for slots in the first learning path. There you can see for containers, clone Docker app in the root. There's a Dockerfile, right? And you can go and do a build and things like that. So I hope that that's made sense. Uh, it's critical to understand that the container registry is more than just a store for container images, right? It's actually a great part of your process and part of your DevOps scenario. To this end, maybe just one last sort of just run around this. You will see if you clone or if you go and fork this Docker app repo of mine, you should notice under my actions, there's going to be a workflow, and you can see there, build push AKS. So what I'm doing in this GitHub workflow is I'm essentially creating a new container registry, publishing a container image into that container registry. Then I'm creating a new Kubernetes deployment. I'm deploying Kubernetes to Azure. You can see that's happening down here at the bottom. You can see deploy AKS using Bicep. And then towards the end, I ensure that my Kubernetes service has got access to the container registry that I created in the previous step, that one over there. And then lastly, I basically deploy, and then I sign into my environment, and at the bottom here, you will see I'm actually deploying that new container image to that Kubernetes cluster. I've done the same here for deploy to Azure Container Apps. I've done the same here for deploy to Azure Container Instances. So most of these are typically just going to work. Very nice for you to actually go and mess around and check them out. The last thing I mentioned, authenticating using Entra ID, the admin username and password. I mentioned I'd show that to you a few seconds ago. Let's just quickly talk about these scope tokens, because you'll notice if I go into scope maps here in the container registry, I can go and add a scope map, and I can say that this is our desktop apps, or whatever the description is, and I can go and specify I want to be able to read, delete pretty much everything for the container app. But you'll notice that I can go and specify quite granularly at repository level what permissions you're going to have. So if there was multiple container apps in here, I'll actually be able to say, Docker app number 1, this app number 2, the backend API, all of these different container images I want to scope together and group together and create a scope for them. I'm going to hit the create button, which will essentially create this desktop apps scope of mine. And the minute I've done that, I can go for tokens here. I can add a token and say that this is for the desktop apps. I can specify a filter. There you can see I pointed to my scope map, and then I can hit the create button. And what I'm going to do here is I'm going to run a Docker log out. So I'm going to log out of that container registry quickly. Now, my Docker desktop would have not remembered those credentials now. And you can see there's desktop apps. And at this point, there's password 1. I can set an expiry date if I wanted to, but if I click on generate, you'll see that it essentially will generate the password for me. And there's actually a Docker login command that I can log into that scope. And at this point in time, I can say Docker login, desktop apps. And because I've got that credential set now and scope, at this point in time, I should also be able to pull that container image, because that scope is giving me access. Is actually up to date, which is why it's not putting. Okay, a couple of minutes left here. So what we've done here, folks, is we've said, all right, well, there's definitely a difference between containerized applications and typically the way you build and store those container images versus your standard type of application that's typically a binary type application. Everything is packed into that container image. The question might be, how do I run this now? So if I wanted to run this inside of Azure, what do I do to run this? And this is there's really two parts of the course here that you need to be mindful of. The first thing is they talk about Azure Container Instances, right? That's the one. And the other one is Azure Container Apps. These two are fundamentally different in that Azure Container Instances only allows you to create a single instance of your containerized application. So with Azure Container Instances, here's my escape button here. With Azure Container Instances, we're basically saying, yeah, bring your container image. You might have a supplier that is telling you our app just runs as a containerized application, and you might not have any infrastructure or other resources or services to run containerized applications. Maybe you just want a single instance of Redis cache available as a containerized application. Azure Container Instances is perfect for that because I can give it a fully qualified domain name if I wanted to. I can also run it as what's known as a container group. And a container group essentially allows me to add, I'm not going to explain them into too much detail. It's going to allow me to run init containers and sidecar containers. Init containers is more or less just an initialization type container that you might have. Maybe when before your container starts up, you first want to create some folders, move some content around, whatever the case is. A sidecar is typically another containerized application that you might actually be using as part of your deployment. So for example, with a sidecar, we're not doing SSL termination in container instances. So with a sidecar, what we can do is we can run something like Nginx as the sidecar, which means my user hits Nginx, does the SSL termination, and Nginx connects with standard HTTP to my containerized application, returns results, encrypts it, and send it back to the user. So with container instances, you're not going to be able to get scale from this. Okay, that's critical to understand. And let me show this to you quickly. I'm going to go container instances. I don't think I've got anything running right now. In fact, I'm going to create one quickly. You will see that this is actually quite quick. I'll put it inside prod. Inside my AZ204 resource group, I'm going to go Jazz204 ACI. I always like to say some PaaS services are more PaaS than others. You'll see in a minute what I mean by that. You can see that I can specify availability zones, standard or confidential compute. I'm going to go with Azure Container Registry here, and I'm going to point it to my container registry and just select that image. Docker app, latest, thank you very much. You should notice here that I can change the size. So for Azure Container Instances, you do get to specify the size. Notice at the bottom there, none for GPU. The reason for that is purely because I'm in the wrong region. So if I go to something like East US, right, and I change this, East US is just a bad example here. I happen to know that West Europe is a candidate. Why is West Europe not the candidate? Right, let me just choose standard and just flip it over a few times there. Change the size. Very, very interesting. No GPUs available. You used to have GPUs in West Europe. Maybe they've scaled down my tenant slightly. But you should notice that you can add, I think it's up to 4 different GPUs. Some of those, NVIDIA GPUs. There you can see I can give it up to 32 CPU cores, and I can give it up to 256 gigs of RAM. Now, that's going to be That's not going to be cheap to be running. There might be cheaper ways of running a containerized application. However, if your maturity in containerized applications is quite low, you're not running Kubernetes, you don't really run any containerized apps, then Azure Container Instances is perfect for you, right? Because Azure Container Instances, you'll notice once I provision this thing, let me just quickly deploy this. It's going to take a few seconds. You can networking. You can see how I can access this. I'm going to go Jazz 204 at this time. Some monitoring components. And then under advanced, you will see that I can actually go and add some key pair values. In this case, I can say the site name is going to be Azure Container Instances. Okay, so I'm going to click on Review and Create. It'll create this container instance. It'll just take a few seconds. Okay, validation passed. Now remember, I can also run it on virtual machines in Azure if I wanted to, but then you have to control and manage that operating system. You could also run containerized apps in app services if you wanted to, but again, you only get limited scale for that. So what I always recommend is if I go for technology choices, you can literally do a search for technology choices for Azure solutions. You should notice that there's a compute service there, and in compute, you can go and decide and follow this decision tree, right? Do you want to migrate, right? Use lift and shift, possibly use virtual machines. Do you want to build? Use virtual machines. Is it event-driven workloads? Use Azure Functions. Do you need full-fledged orchestration? No, Azure Container Instances. Do you need orchestration? Yes, you can use something like Azure Red Hat to OpenShift, Azure Kubernetes. Do you need Kubernetes capabilities and access to the Kubernetes API? No, you also then can use Azure Container Apps, and that's what I'll talk about next. So I'll go to this resource, and immediately what I want you to notice here is if I copy that URL, there we go. If I copy that URL, it's going to give me access to my containerized app now, and you can see it's reading this environmental variable from that Azure Container Instance. But take note there, it's not secure. It's not doing SSL termination, right? So a nice exercise for you to do is if you do a search for Azure Container Instances sidecar Nginx, then we've got a very nice walkthrough that will essentially allow you to create a self-signed certificate and eventually deploy, some of that configuration and secrets to your environment, and then you'll essentially create the container instance, and it'll then, it'll essentially use what's known as a container group to deploy this, and you can see there's Nginx, and then whatever other applications you are typically deploying, that one there. There's Nginx, and you can see there's my web application. All right, so it's well worth checking that out. If I pop back, if I go into my slides are hanging. Whoa, give me a second. Shift F5. Slide. So Azure Container Instances, very simple, easy to manage, single instances of your containerized applications. Cannot be added to Azure load balancing solutions. So this won't be added. We won't be able to add Azure Container Instances to an Azure load balancer as a backend pool, for example. You can use something called container groups for running sidecars like Nginx, or for init containers, these sort of scenarios. And there you can see AZ Container Create, the resource group, the name, the image I want to be using, and whatever environmental variables I'm keen on actually showing there. So head back in there. There's my application, and you'll notice that this scroll bar is quite big. There's not much I can do. I can stop it, I can delete it. Other than that, there's not much I can do. Right, there's my Azure Container instance. You can see it's running an instance of that containerized application. If I had some init containers and sidecars here, those container images will also show on this list. All right, so that's the first part, Azure Container Instances. For the second part, I want us to talk a little bit about Azure Container Apps. I'm not going to spend too much time around this. Essentially, what you want to be aware of is if you want to deploy containers at scale, you've got multiple options in Azure, right? You can use Azure Kubernetes Service or you can use Azure Container Apps. Now, how it works with Azure Container Apps here is with Azure Container Apps, I basically start by deploying Azure Container Apps environment. An Azure Container environment is the equivalent of a Kubernetes cluster. So it's the infrastructure, the cluster master, all of that, it's all abstracted away from you completely. And then on top of that container apps environment, I can go and create an application. So whether I'm creating the environment alongside the first application or whether the environment already exists, it doesn't matter. This application that I create can scale. Right, so run multiple instances of my containerized application and add them, and add them to something like what's known as an ingress. So there might be some sort of an IP address here, and my users are going to hit the IP address. It's basically going to be that ingress is going to be making a load balancer available, and that load balancer will balance the load across all these different instances of my containerized application. Now, I've already created a container app in my environment here. So you'll notice if I go for container apps, you will see that there's my container app. I suspect I broke this one, but never mind that. You can see I actually messed it up completely. So what I'm going to do is I'm going to create a new container app. Let's see if we can do this very quickly. That same resource group, Jazz 204 app 2. And this time I'm going to point it to that same environment. You can see at the bottom there's my environment, right? So I'm using that same environment again. I can create a new one if I wanted to. In this case, I'm going to go for the container. I'm going to specify it's in this container registry. There we go. Specify the image, Docker app, and then the tag. Right? Some command overloads. What is the stack I'm using? .NET. What is the workload profile? And you can see there X amount of CPU cores and RAM per instance. And of course, in here, I can go and say, the site name is at this point in time Azure Container Apps. I can also create secrets in Azure Container Instance, Container Apps that point to a key vault if I wanted to integrate some secrets from a key vault. I'm going to accept traffic from everywhere, allow secure connections. Now I'm just going to click on create. Now, because the container app environment already exists, what I've got is I'm literally just deploying a new container image onto that existing Kubernetes cluster, if you like. You don't have access to the Kubernetes cluster. You've only got the access that we are giving to you through our portals and different tools. So if we can just quickly touch on the slides, we've got the concept of Kubernetes rolled into Azure Container Apps. These container apps has got some ingress configuration and controllers that you can control the ingress and some of that load balancing if you wanted to, and also configure some of the scalability, right? You know, I think we support several containers type scalars, and to that point, you can essentially choose how you want to scale your environment. Is it going to be scaling on the number of requests? Is it going to be scaling on some parameters or whatever the case is? Different versions of your containerized app. So if you bring out a new version of your application, we can create revisions and a revision 2 of the containerized application, which means that we will start draining out the request on revision 1 and start routing traffic to revision 2 if you wanted to. There's also native Dapr integration in Azure Container Apps, where if you think, for example, of things like secret management, API endpoint management, those sort of things, right? That Dapr integration is native to Azure Container Apps, and we will even bring some Azure services for that. So we'll use the key vault for your secret management, for example. And then I mentioned secret management, also direct integration from the Azure Container Apps environments to your key vault. And you can see there's a good example. AZ Container App Create, the name of the container app, the resource group, the image I want to be using, the environment I'm going to be using. I can specify the ingress, a target port, for example, a registry server I'm going to be using where the registry image is going to be stored, the registry password and the username, and then some additional query parameters that you can see there, the fully qualified domain name, for example. So once this has been created, you can see that there's my JAS204 app now, and it's going to give me a URL, and you should see now that it's running. Welcome to the Azure Container App site. It's running now in that Azure Container Apps cluster. And if I keep hammering this and really hammering this, you should see under my revisions and replicas, you should start seeing some additional replicas come through here. So this might take a few seconds to start happening, but if I just keep refreshing this a few times, then certainly it's going to start scaling. All right, I'm going to refresh a few times here, but I've covered what I wanted to cover. Let's just quickly wrap up here. I see I've got a few minutes left. Just in conclusion, why containerized applications gives you a very portable, flexible, and scalable type scenario, very well suited for things like microservices type architectures. Also, really good integration with most DevOps tooling that you might have, and a lot of industry standards here. So I when I started training as part of my current role, I reckon probably about 8 to 10% of people were running containers. I always ask the question on my courses. And nowadays, probably 60 to 70% of my learners are using containerized solutions. So what are some of the key concepts to master? Make sure you can at least read a Dockerfile for the exam, as cheesy as that sounds. Make sure you understand what some of the features and some of the commands are for the container registry, and then get your head around what are the differences between Azure Container Instances and Azure Container Apps. Azure Container Instances, just the instance of your containerized app. Azure Container Apps, scale for your containerized application, just more like you might get out of a Kubernetes cluster. And folks, that leads me up to the question, are there any questions?
Hi, we have a question from Lakshmi.
Just so that I can see. Can explain use of Docker ignore and its significant of use. Very similar to a git ignore. There's certain artifacts that you might want to make part of your containerized service. There's certain files and content that you might not want to make part of your containerized solution. So it's not really a big part of the course, but suffice to say, you might want certain items not to be in your containerized application, right? So you use a Docker ignore to specify, I'm not going to use that, I'm not going to use that. So it's just segregation of what you actually want in the containerized file. I hope that answers the question. Let's see. Register. Here we go. Can you explain use Docker ignore? I think we mentioned that. Having the session. Thank you very much, Kidimalu. If you're interested in finding out about hello from the Netherlands. All right. It looks like that's all the questions, folks. Gosh, only one question. All right, I did go through that quite quickly, so please, and let me, while we've got time here, if I go search for AZ204 certification, that's just the study guide. Let's go find the exam. That's the easiest. So we've covered so far, app services, functions, blob storage, Cosmos DB. We covered containerized solutions, and you'll see containerized solutions is split into three parts. Managing, the images with the container registry. There they talk about, the container registry, the elements of a Dockerfile, everything that I spoke about earlier, more or less. You can see there's all the most of the information. And then towards the bottom there you will see Azure Container Instances and Azure Container Apps. Okay, so folks, if there aren't any further questions, I do want to thank you for your time. I hope this series is valuable for you folks, and that it at least drops the concepts so you don't have to figure out conceptually what some of these services are and how you might be using them. But from my side,
Um,
thank you very much, and I hope you enjoy the rest of your afternoon.
Johan, we got another question while we were explaining and showing us the exam from Kyling.
How do you propose promotion a lot of Docker images for microservices architecture? I've got one question. How do you propose promotion of Docker image for microservices architecture when there are over 50 items to promote? I'm not really sure what you mean by that, to be honest with you. I honestly don't understand what you're talking about in terms of promotion. But as per usual, you are welcome to reach out to me on my on my LinkedIn profile. You should be able to just go to akka.ms/Johan. That's my LinkedIn profile. So if I couldn't get to your question and the answer behind that, please reach out to me on akka.ms/Johan. I'll gladly, see if I can answer some of your questions over there.
Thank you. I think that was all for today, Johan. I'll see you next time. Thank you all for joining, and thank you to Johan for the session today. We are always looking to improve your sessions and your experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat, and we'll see you on the next one.